All right, so we're going to talk about precipitation in our drainage basin for our pre-development. So we're going to look at pre-development first. Now, in pre-development, like I said, I showed you the contour map here, and this is the contour map overlaid on top of an aerial. I also have the drainage basins already delineated, and we'll talk through those. When we're looking at pre-development, we have to actually do our design twice. We'll look at it for pre-development design standards for figuring out our runoff in acre feet or acre inches and our peak discharge in CFS. So our address we'll have to use to figure out how much precipitation comes down. APOPCA says you have to use 8.6 inches for their design storm event. We'll take a look at what the NOAA Atlas has to say about how much they believe the rain for a 25-year, 24-hour storm. We'll look at the outlets. Where is our point of analysis? We'll look at the soils. We'll look at the land cover. These first ones are always going to be, these are going to be all the same steps that you'll have to do in post-development. We'll take a look at the time of concentration. We'll look at sheet flow, concentrated shallow, or shallow concentrated flow. If there's a channel, we'll take a look at that. We'll also look at our initial abstractions. That means how much water actually comes out of the system before we have runoff. We'll look at runoff in inches. We'll look at a formula and look at some of the nomographs for that. And then we'll look at runoff in acre inches. And then we'll look at peak discharge using the graphical method. We'll also do the peak discharge in a tabular form later in class. So the NOAA Atlas, if you click on the hyperlink, it'll take you to the site and then type in the Vota Road address. But over here, I did the same thing. So the 25-year, 24-hour says 7.51 inches. APOPCA says use 8.6. So who controls? APOPCA is going to control because they're the jurisdictional agency over this design. So even though it says 7.51, we'll use the 8.6. However, they don't stipulate the 100-year or the 10-year, so we'll use those for our designing of our roads, those two design methods. Okay, so when we're looking at this, we say, what are the high elevations and low elevations on the site? Because we have to figure out where our drainage basin goes. If you look at this, we have an 87.7 contour. We have 82 all the way down to 68. We have 81 down to 77. We have an 83 on this side, and we have a 77 on this side. So our low points, there's going to be one to the west, one to the north, and one to the east. The rest of this actually flows down and goes into this low-lying area. Big scheme of things, we have to figure out what's actually coming to us. This is a USGS map. What water's coming to us, not just from our site. Our site's this little rectangle here, or almost a square here. We can see that here is a ridge line through here. And we can also see this is a valley through here, so water goes down. This clips our edge. Now, when we're looking at this, we have to look at what else is coming to us. If this is clipping the edge, that means some of this water may be coming to us. So we might have water coming off-site. And the project next to us, which is called the Dominish Estates, is actually coming to us. It has a dry basin, and it either runs down our edge that we have to bring into our site or make it continue down the edge of our site and not bring that water to us. We have to account for all water coming to us. We can't block off our site, because if we block off our site, we'll flood the people around us. So the USGS maps are really good to give you a big overview. Here's a Vota Road, and then there's actually a gas pipeline that goes through the site. So we're over here, okay? Now, this is another topographic map, so we can see what our drainage basins are looking like that. What I'd like for you to do is take I'll have this posted as a PDF, and I'll have you create a drainage map for us, okay? So you'll delineate it. Like I said, you can already see that there's a 68 over here, there's a 70, almost a 77 over on that corner, and an 84 up here, okay? And if you continue with the videos, you'll see me actually draw that, okay? Now we have to talk about the areas. So I've already done this in the area up north, and there's a glitch. I'm not happy with that. The computer program actually delineated this for me based on my contour surface. So some of you all have already had some of the Civil 3D classes, and you created a surface out of all of the point elevations. That's what this did, and it created its own contour. Now the other thing that I'm showing in here, so the north half has a 0.27 acre basin, the west half is a 3.79 acre basin, and the east half has a 1.41. So the total area is 5.47. Now we have to account where this water goes. Ultimately, pre-development, it's going to be a total amount of water. In post-development, we're going to discharge in one point. But here's the thing. This basin here, if we put our pond at the low point of the site, we're controlled by the runoff of the west basin. We can't be accumulative to all the basins because we're not discharging to the north or to the east. We're only going to be discharging to the west. So how much ever water ran off from the west basin is the only amount of water that we can discharge from our site. If we put ponds and discharges on the east and the north, then yes, we could add that runoff that was from the north and the east to that site. All right, I'm going to pause here. Then we're going to take a look at our hydrologic soils group. We're going to take a look at our curve number and time of concentration for our site.